Hello, today we're talking about DNA to protein and how it makes the protein, obviously. For starters, when DNA is like this in its cold form, primase, which is a telomere, goes in it and then starts to separate them and then make two strands, leading and lagging. Leading strand is just a strand that goes off and which later combine back in a little bit, but the lagging strand is where then we'll have DNA polymer 3 start to click on it, bind to it, start copying genetic material. Because genetic material is in 3 stages. It's three codes, 333. And that DNA polymer starts copying that. And along with DNA polymer 1 and DNA ligase, all that. They're all copying and like just making that strand so it can then be sent out to nucleus, to the cytoplasm, to ribosomes. And after all that, it just goes back inside and becomes a regular code back again. And also, important telomeres that are involved with replication of DNA are ligase, primase, a DNA primer, and Okazaki fragments. Okazaki fragments, they aren't telomeres, but they are subunits that come off of the lagging strand, which are just like, this pen is the copy of the DNA. If I was to take this off, this would become an Okazaki fragment because it's just parts that come off. But they say, oh, this is bad, it's horrible, right? No, that's why we have DNA ligase, and ligase sees these gaps and will fill them back in with that DNA, or it'll find another DNA area and put it here to make a whole different set of instructions that the ribosomes use to make. And then we also have transcription. Transcription is just the starting process of the DNA being copied from the nucleus. So this is when it really starts. Like, I'm just explaining an overview, but this is when it's truly starting. And for starters, we'll talk about prokaryotes because we need to know both. But in prokaryotes, it's actually quite simple because for them, it's only one strand is transcribed from the mRNA, and that's really it. Like, it's that simple. I know it's shocking for us all to know, but it's just one strip being copied, done. That's it. But for us, though, it's a little bit more complicated just because we need to have an initiation factor that will start the process for us. And then we also need to have mRNA modifications that splice the introns to extrons. And what that means is that we have the splicing of this intron right here. This intron will then be cut up to make this right here. This came from this, but if it's spliced in a different way, it can make this as well. You see what I'm getting at? So just from this like set of bare instructions, transcription can make it go from this or this, or can just do a direct copy down. So it can have the different ways that's cut up can make it so that it can be a whole different set of instructions. This is why transcription needs to go first before translation, because if we just take this to translation, we won't be alive, honestly. That's all it is. And then we also that doing this is mature RNA that will get sent to the translation and all that. So, overview of this real quick. mRNA, which is the messenger RNA that comes from the nucleus. Ribosomes come in, transcription, and then it goes down, transcription. This is mature RNA, which the RNA is processed, and this is usable RNA for the translation of the ribosomes. Now for the ribosomes. We'll get into the nitty-gritty, which ribosomes will clamp down on it, so it'll be like two parts, 1, 2, clamp, and they're just gonna copy it down, and out of nowhere, the protein will start coming out because it's copying. Oh, okay, I see it. Choom, choom, True, that makes sense. And real quick, just a quick overview of like ATG. So right here it's ATG, which starts it. So it senses ATG, it's gonna start copying. But if it senses UAA, UAG, or UGA, right here's UAA, it stops. No more copying. We don't need it anymore, and that's it. And then we also have, and then those sites, there's 3 sites in the ribosome. There's 3. There's the A, P, E, and they each just doing their own thing. You know, like checks, makes it, checks, copies it down. It keeps going, kind of like a cycle in a way. And then there's 2 that initiated the ATG, because like ATG is just an abbreviation. In prokaryotes, it's 4-melatonin in prokaryotes. In eukaryotes, it's menethylin. And then after this, it's just elongation to make it bigger, and then termination stops it and it gets out and being used. And that's it. Thank you.